What's up, everybody? In this video, we are going to send the prediction information from our Teachable Machine website to Node-RED. This will give us the ability to use a browser to not only visualize our model, but connect the predictions to other devices. In the previous video, we looked at sending data to the server using the ws.send function. We can use this to send the prediction data to the server. The question is, where can I access the model prediction information? If you refer to the Glitch website and look at the README file, you will notice that there's a lot of documentation about how to make edits to the model. Under the Change the Callback heading, you will see there is a Setup Model function that works with the prediction data. If we want to work with that data, we can add our own code to the function. In our Node-RED flow, double-click on the JavaScript template and scroll down to the bottom of the JavaScript. You will see the Setup Model function where we can add our own code. Inside the Setup Model function, below the Update Bar Graph function, add ws.send, open bracket, data, close bracket, semicolon. The data variable is our prediction model. Click Done. Click Deploy and open the website. You will see everything loads normally. However, our debug window in Node-RED is moving really fast. So why is that? If you look at our prediction model, you will notice that the bar graph is constantly changing. Each time the graph updates, we are sending data between our browser and server. Doing this creates a lot of extra work for our server, and we aren't passing relevant data with every request. Let's update our website and add a button. When we click on the button, it will send the prediction values to the server. Before adding the button, let's remove the code that is sending the data every time the model updates. Double-click the JavaScript template, and inside the Setup Model function, remove the ws.send, open bracket, data, close bracket, semicolon, code. Click Done. Double-click on the HTML template. Scroll down until you get to the section with the ID model. Before the closing section tag, add the code open angle bracket, button, type equals, quotation mark, button, quotation mark, on click equals, quotation mark, send prediction, open bracket, close bracket, semicolon, quotation mark, close angle bracket, send prediction info, open angle bracket, slash button, close angle bracket. So what does this do? We created a button, and when someone clicks it, it will run the send prediction function. Now we need to write our send prediction function and include the code to execute it. Double-click on our WebSockets template. Add function, send prediction, open bracket, close bracket, open curly brace, close curly brace. You will notice that writing functions in JavaScript follows a similar format to writing them in C++, the programming language for the Arduino. Inside the curly braces, add ws.send, open bracket, data, close bracket, semicolon. Click Done. Click Deploy and open the site in a browser. Let the camera load and try clicking the button. Have a look at the debug window in Node-RED. Nothing is showing up. Now try using Inspect Element and look at the console. There is an error. It says, data is not defined. Why is this happening? Let's look at our Setup Model function in the JavaScript. Double-click the JavaScript template and scroll down to the Setup Model function. This has to do with the concept of the scope of a variable. The variable data in the Setup Model function is local. It cannot be accessed outside of this function. Click Done. Double-click on the WebSockets template. We will need to create a global variable to track the prediction data for our program. We will define it so all functions can access it, and it will hold the value of our latest prediction. At the start of the code, add let prediction data semicolon. This creates a variable titled prediction data that we can access globally. Update the ws.send inside our send prediction function to send the prediction data variable. Click Done. Double-click the JavaScript template and scroll down to the Setup Model function. Inside the function, type prediction data equals data semicolon. This will set our global prediction data variable to the value of the local data variable inside the Setup Model function. Click Done. Click Deploy and open the web page in a browser. Once the camera loads, click the button, see what you get in the debug window. It should show up as a bunch of objects. When we send information that is an object using WebSockets, we need to convert it to a string before sending. Double-click on the WebSockets template and inside the bracket add json.stringify open bracket prediction data close bracket. Click Done. Click Deploy and Test. Now we should see the entire data as a string. Finally! We are now passing our data to the server when we click the button. Since we have a string, we want to convert it to a JSON object so we can work with the data. Drag a JSON parser to the workspace and connect it to the WebSocket in Node. Drag a debug node to the workspace and connect it to the JSON node. Click Deploy and test out the website. You should see that we now have an object with our prediction data. Let's do one more thing. Let's organize our data so the highest probability is our first object in the array. We can do this by using a sort sequence. Drag a sort node onto the workspace and connect it to the output of the JSON node. Double-click the sort node. We want to organize our results based on the probability of each. To do this, click on the down arrow in the key and select expression. Type probability. Ensure the order is descending. Click Done. Drag a debug node onto the workspace and connect it to the sort node. Click Deploy and open the web page in a browser. When you click the button, you will see 3 debug outputs. The first is the raw string. The second is the string converted to a JSON object. And the third is the sorted JSON object with the highest probability as the first object. At the end of this video, you should be able to send the prediction information from a Teachable Machine to Node-RED using WebSockets and sort the data according to highest probability.